Here with me is Professor Jeff Magee. He's the Faculty Dean of Engineering here at Imperial College. Welcome, Professor Magee.
Hello.
So today I'd like to talk to you a little bit about healthcare innovation and the role of engineering in global health itself. So in your opinion, what are the main challenges affecting global health today?
I think one of the major problems is dealing with an aging population, providing an appropriate standard of living for that aging population. We have the increased prevalence of non-communicable diseases. We have the increased pressure on the environment brought by urbanization and increased population generally. Many of those problems of the environment require solutions in the engineering domain to do with dealing with air pollution, with water sanitation. But the problems of the resources to deal with these problems and the unequal distribution of those resources across different nations are one of the problems we have to deal with.
So what value would you say the Institute brings to the Faculty of Engineering?
I think these problems, which have got a clear medical dimension and engineering solutions, I think the Institute provides a platform for bringing together medics and engineers to provide appropriate solutions to many of the world's big problems. I think we have a great example of what can be achieved when engineers work with medics in the Hamlin Center for Robotic Surgery, which brings together leading academics from the Department of Surgery in the Faculty of Medicine, and from researchers in computing and bioengineering in the Faculty of Engineering to provide innovative solutions such as iSnake, for example.
So why is it important to take a multidisciplinary approach to global health needs?
These are complex problems. No one discipline can address the full range of problems. A good example of what can be achieved is that we have Mike Templeton in civil engineering working on water sanitation, working with the schistosomiasis control initiative in the Faculty of Medicine. Both of those dimensions need to be put together to deal with those problems. I mean, I mentioned the Hamlin Center for Robotic Surgery, which brings together people working on vision image processing. It brings together mechanical engineers, it brings together surgeons. So you need many disciplines to solve these complex problems. We have a great example in a collaboration with the Royal College of Art in our Innovation and Design Engineering MA/MSc course, which is a 2-year course. Recently they looked at dealing with the Paralympics. It was sponsored by Rio Tinto. They provided some innovative solutions and a new take on what could be done in the Paralympic initiative. And actually that collaboration between the Royal College of Art and Engineering and the medical faculty is now embodied in the new Helix Center for Design Healthcare, which brings together designers, engineers and medics to provide innovative solutions to medical problems.
So student-led initiatives play a key feature within the Faculty of Engineering. Can you tell us a bit more about some of the current student initiatives and projects aimed at tackling global health within the faculty?
We recruit really bright students. The students are also very socially aware. I mean, I can illustrate this by example. In the electrical engineering department, they encourage student-led projects. And a few years ago, students got together and looked at one of the major problems that faces developing countries, which is the provide of electric light, so that people aren't, their working lives aren't dominated by the sunrise and sunset. So they looked at that problem, and what they decided was that they needed to provide a source of energy. And so what they did was provide what they called energy kiosks, which is, and this is something called the Equinox Initiative, which is providing solar energy driven kiosks which charge batteries, which are then can be used by the local population. But they fitted that into the social environment by providing an economic model to replace what was there, driven by petrol-driven generators, in a much more efficient and more applicable and more widely distributed systems. Those students have gone on to develop a company that's now producing the energy kiosks, and they've now been deployed not only in Rwanda but in other parts of Africa and the developing world.
So IGHI believe that working collaboratively is the best way to get the best results and get the biggest impact. Are there any current research projects happening within the faculty that IGHI could cover or promote?
Yes, indeed. Last year we were very successful in the very competitive European Synergy Awards, and one of those problems is dealing with the world problem of obesity through a combination of engineering and medicine, in particular to looking at an implantable device in the vagal nerve to control appetite. This is a collaboration between Steve Bloom in the Faculty of Medicine and Chris Tumazu in the Faculty of Engineering. Chris Tumazu is our first Regis Professor. We were very pleased to get, as part of the Queen's Jubilee celebrations, to have a Regis Professorship awarded to us. And the fact that that's held by someone who's working in this multidisciplinary field between engineering and medicine is, I think, something we should celebrate and something that I would be very happy to help IGHI promote.
Well, it's been really interesting talking to you today. Thanks for taking the time out to be interviewed.
It's been a pleasure.